All right, so let's play around with a 3-set universe. So I have a table of numbers related to blood types, and the blood types are related to antigens in the blood. So we have the type A antigen, the B antigen, and the RH antigen. And either you have the A is present or not, the B is present or not, and the RH is present or not in each person's blood. And these are the three antigens we use to talk about blood type. So I have a universe here. A universal set is blood types, or antigen information, I should say. Information for 150 people. And then there's a summary of that information given in this table here. So I'm going to try and take that table and put it into a Venn diagram. So my 3 different sets in my universe here are going to be the set for the A antigen, the set for the B antigen, the set for the RH. So let's say that one there is A. This one right here is going to be B. And down here, we'll let that be the RH antigen. Now, they say 60 people had antigen A, but of those 60 people, some of them also had B, some of them had B and RH, and some of them just had RH but not B. So that 60 people is in this whole circle, but this circle is made up of 1, 2, 3, 4 different rooms. So I don't know where those 60 people go. So I'm not ready to deal with this fact up here or that fact up there or that fact down there. Now, same thing with the A and B. The A and B, so let's highlight that, is this crescent shaped right here. And some of those people go here and some of them go here. I don't know which yet. So it turns out I can't use that information yet either. So the only thing I can use right away is that one down there, that there's 9 people that had A, B, and RH all present at the same time. And so I'm going to put that 9 right there. Now, once I have that 9 there, then I can backtrack for some of these others. Like, for example, this A and B one, I've already accounted for 9 of those 12 people. There must be 3 more people that are up there. So there's 12 people that had the A and B antigen. 9 of them also had RH. 3 of them had the A, the B, but not the RH. So that's what I get when I put these 2 together. So I'm going to put pluses on those because I've done those. The A and the RH claim was there were 46 of those altogether. A and RH over here. I've accounted for 9 of those 46. So that's going to leave me, what, 37 here? 37 plus 9 is 46. So here's those 46 that have A and RH. Some of them also have B. Next one, so I've got that one covered. B and RH, there's 17 of those total. And again, that 17, I'm just going to draw this in red. This region right here, the people that have B and RH. I've already accounted for 9 of them. So that's going to leave, what, 8 out here? 8 plus 9 is 17. Yep, that works. So now I've accounted for those. Then heading out from there, once I've got these 3 rooms filled, I can tell you how many goes in there because I know for A, I need 60 total. So then if I have, let's see, 37 and 9, that's that 46, plus another 3 is 49. So for the A's, if I take 60 minus these 49 here, gives me 11. Yep, that live here. And so I should double check that. 11 plus 37 plus 9 plus 3 is going to add up to 60. So I would whip out my calculator to double check that. I think I'm good there. B, there should be a total of 27. I've accounted for these 17, 18, 19, 20 of those 27. So I believe there should be 7 here. Double check by counting them in a different direction. 7 and 8 is 15. 15 and 9 is 24, 25, 26, 27. Yep, there's my 27 who have the B antigen. And let's see, RH had 123. We've accounted for 37, 9, and 8. So let's see, 37 and 9 is 46, plus 8 is 54. So I need to figure out for the RH, what is 123 minus 54? Without a calculator, let's borrow 9, 5 from 11 is 6. Looks like 69 belong here. And we should double check that. So if I take that 69 plus there's 37 plus the 9 and the 8, make sure that comes out to that 123 there. So 9 and 7 is 16 plus 9 is 25 plus 8 is 33. 3 and 6 is 9, 10, 11, 12. There's my 123. Okay, so it does check out. So now, again, what have I done so far? I've kept track of the people that have the A antigen, the B antigen, and the RH antigen. And a person can either have A or not, they can have B or not, they can have RH or not. So the other thing to consider is, what if they don't have all 3? That's possible. So then I have to know, well, how many people were accounted for total here? So that total count of those right there, that would be the number of people that have A union B union the RH. And another way we say that is A or B or RH, be another way to say that. That means count them up without overlapping. So I just have to add up all of those numbers. So I'm going to start with the RH crew. I know there's 123 there. Then I just have to add on the 11, the 3, and the 7. So 123 plus 7 is 130, plus 3 is 133, plus 11 is 144. Did I get that right? 123 plus 11 plus 7 plus 3 gives me 10, 11, 12, 13, 14, carry the 1. Yep, 144. So I just counted up here, again, assuming I had 123 in this RH circle, adding those other numbers, the union of those was 144. I'm supposed to have 150 people, so that must mean there's 4 people out here that have neither A nor B nor RH. How would I write that down? So a couple ways to write that down. One way to write it is to say, okay, take that set we had a minute ago, A union B union RH, and look outside of that by putting a bar over the whole thing. So everybody that doesn't have any of those. Now, sometimes a slightly different notation we see there would be A union B union RH in parentheses with a C for the complement, right? So this or that mean find the complement. And we just calculated this 4 in that group. Okay, so just some other things to consider. When we talk about blood types, if somebody has the RH, we call them positive for the RH. So for example, if somebody's blood type was A positive, that means that they have the A antigen and they have the RH antigen, right? Intersect, they have both of those. So if I wanted to know how many people are type A, that would be doing this right there. Find, oh shit, I think I wrote some things backwards here. I hate when I do that, don't you guys? I did. Or is a union, and I wrote the intersection sign there. Let's fix that. Oh, my tablet's going to die soon. Error. So let's erase, and then we'll do the error in a different color to correct it. The or was correct here, but I had my unions and my intersections messed up. So I wanted the union here. Let's go red. Union is the or. Union, 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 union. Down here, A positive means they have the A antigen and the RH antigen. That's the intersection. And I want to count them. So another way to state that is how many people had A and is the intersection RH. So if I look up at my table here, A and RH, that would be this, let's see. Oh, take that back. A positive is a little more complicated that it's A and it's RH, but it's not B. So I would also say and not B with either a line over the B or the complement symbol. That's what I want. So down here, and we'll get to those other 9 people in a minute, intersect B complement. So this set right here, I'm going to highlight that in green up there. So they have the A and they have the RH and they don't have B. So that would be this group right here, A and RH, but not B. So that would be 37. So then what about this 9 right there? What about that 9? So what do those people have? They have the A, they have the B and the RH. So I need a new page for that. So they have A and they have B and they have RH. And so people in that category would be A, B, positive. And that's that 9 people. A and B and RH equals 9 people. Now, we didn't name these 4 people out here except to say that they didn't have the A, the B, or the RH. And when the A and the B are missing, we call those O. So if A and B are missing, it's type O. And then we can have O positive, meaning there's no A, no B, but there is RH. And we can have O negative, so that would be no A, no B, and no RH. All 3 are missing there. So we already named this set right here with set notation. Let's try to name this O positive one here. So looking back at my picture, the O positives, they would have to be outside of the A circle, outside of the B circle, but inside RH. So that would be this 69 right there. So I'm going to redraw that here. So here's our universal box. And we have A, we have B, and we have RH. And what we want to do is give a name to this group here, those 69 people. Okay, so what do we know about those people? So that's, let's see, this group right here that we're working on. We know that they don't have A. So for set notation, we could do either A complement or A with a bar over it. They also don't have B. So and would be the intersect, B complement, and intersect, they do have RH. So that right there would describe this region out here. We're outside of the A circle, right? Complement of A, outside of A, and we're outside of B, and we're inside of RH. So that would be how to describe that region right there. So once we have a Venn diagram and we can fill in each of these regions, and again, the regions we're talking about here, let's say this is region 1, 2, 3, 4, 5, 6, 7, 8. So 3 sets break up a universal set into these 9 different areas. 1, 2, 3, 4, 5, 6. So I can't count 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 different regions. Once we have that filled out, we can basically answer any question someone asks about them.